Hello, welcome back to the third installment of our discussion about faster-than-light space travel. I'm still using some random footage from my second Battletech campaign. This is actually from just before the footage I used in the previous video where I managed to salvage that huge atlas, which I'm still super stoked about, and I'll have more use of the atlas in the next video. But there are some big hits in this one, and I managed to put up a strong defense protecting this factory here. So, please enjoy this asymmetrical fight while I discuss the effects of long-term spaceflight on the human body. I'm going to get into that while I play shoot 'em up with some of my favorite robots in the background. Before I do, I like to throw a thank you and a big shout out to all those who have seen my previous videos, for the likes, the comments, the few odd subscriptions. You guys are the best. And if you haven't already, subscribe. Won't you please? Because, there's more to come. Even if this specific video doesn't interest you, there might be others in the future that could. Or some of the previous ones that did. Anyway, back to today's topic. Another of the problems facing humanity would be extended spaceflight, and the effects of zero gravity on the human body. If somehow we do manage to achieve a significant fraction of the speed of light, say we manage 24% of light speed, which is something roughly on the order of 72,000 meters per second, it would still be quite some time before we could manage to reach the nearest star system at that speed. Proxima Centauri would still be 15 to 20 years, depending on, it would take 15 to 20 years to complete the trip, depending on how long it took to accelerate and then decelerate from that, to and from that 24% of light speed velocity. So, if we had a crew that was willing to take that 20-year trip, cooped up inside a spaceship, and a spaceship that was capable of sustaining them for that long, we'll ignore all those other logistical problems and discuss what would happen to the bodies of those astronauts or cosmonauts or whatever term you want to use for the crew. Some of the most notable problems for the human body living in zero gravity is muscle atrophy and skeletal deterioration. Other less significant but perhaps more disturbing problems include the redistribution of fluids in the human body, causing something known as moon face, making a person's face appear larger or swollen. And there's other problems associated with this: blood flow, blood clotting, lower production of red blood cells. All the different fluids in the human body are interacting differently with each other and with the human body, not having, that gentle tug of gravity pulling them down. Nasal congestion, sleep problems, general loss of body mass because of that muscle deterioration. And, not having to use the muscles in your legs and your back and your neck to stand. Often problems with eyesight, change and shape in the structure of your brain, or even the activation of latent viruses that were already, internal in your body. Excess flatulence, just because of the way not having gravity affects your gut. In 2019, NASA performed a twin study where one twin was sent into space for a year and the other remained on Earth. And they then compared the two people when the other one returned from space, and NASA was able to note several differences between the other twin and the one that had been in space. Not just physical or cognitive differences, but even in their very DNA, they were different now. So long-term spaceflight, even only for a month at a time, is going to cause significant physical changes to the human body while in a microgravity environment. Plus, then you have to worry about radiation exposure and the other elements which you would be subject to when outside the protection of the Earth's atmosphere for any length of time. I'm sure it's not hard to see how, all of these problems compounding on top of each other could make a long-distance spaceflight at the very least uncomfortable, if not outright dangerous. I'm not even bothering to get into any of the other, more psychosomatic type problems that are harder to predict and measure, they're a more case-by-case type event. Either way, the person will get taller. Without the weight on your back, you'll stretch out, sometimes inches, sometimes painfully. And it'll be even more painful when you return to Earth and have to recompress again. Which, personally, to me, that's why I am not going in space. So, without getting too deep into specific details, as they may consume too much time, There's all kinds of other effects that are specific to the individual. Weightlessness can, mess with your sense of balance since it affects the fluid of your inner ear. It may cause motion sickness. One might get severe headaches as all that fluid redistributes more evenly through your body and increases the total volume of liquid inside your head, which could also put pressure behind your eyes, possibly constricting your optic nerves, messing with or even taking away your vision. Other weird things can happen to your sense of taste. Even just losing the calluses off the soles of your feet can cause problems once you return Earthside. Or, how difficult it is just to cry, because you cannot shed tears without the forces of gravity pulling them out of your eyes. Instead, you're just filling your eyes with water because there's no gravity, there's nothing pulling the tears out of your face. Some of these problems are just annoyances, and some are dangerous, even life-threatening, and only get worse once you return to a gravitational field. The longest known, as an example, the longest single spaceflight ever done was performed by a Russian man whose name I can't pronounce, and I apologize for butchering it. Valery Polyakov? It's spelled Valery Polyakov. His spaceflight was 437.5 days in one continuous flight. It's longer than a year. It's even longer than the man that was trapped on the Mir space station during the collapse of the Soviet Union. So, for all we know, this is the longest possible period for a person to reside in space without serious harm occurring. Specific forms of exercise, rotating habitats, and centrifuges can be used to simulate gravity and its effects and eliminate some of these problems that arise from not having gravity. Depending on the extent of the exercise and, the other effects of bone loss and muscle weakness and such can be alleviated or prevented, possibly. But to do this, time and effort must be given regularly, every day, multiple times a day, to specific exercises and activities. Time and effort that isn't being spent on maintaining and operating and piloting the ship or doing science experiments or whatever it is the crew needs to do. Time and effort that requires more calories, more water, more energy, and so on. Which, when in space, every ounce of food and water you're carrying is so precious. But unless one is likely, unless the astronaut in question is constantly in this, rotating habitat, exercise, centrifuge, it won't prevent any of the other minor problems, such as the spine decompression or, the changes in the sense of taste to the redistribution of fluids, moon phase, etc. So in order to combat these problems with our current technology, the spaceship would have to spin. Like using a giant soda can as a spaceship and spinning it on its long axis so that the crew could walk inside the cylinder's rotating walls, creating false gravity with the gyroscopic forces. This is the easiest method to simulate gravity, but still introduces more complexity in engineering and expense and other, problems when constructing the ship. As a sci-fi author, I feel obligated to mention other things, since I'm always looking to the next level of technology. I think it would be best to have the crew's minds downloaded into the ship's computers, and not even have physical bodies for the duration of the trip. And then use some stem cells and grow them new cloned bodies upon arrival at their destination, and then re-download their minds into the flesh bodies. Or just build them machine bodies, turn the colonists into Terminators, and then none of them will have problems like this. None of those problems will ever befall them. For now, that's just wishful thinking. My point is, without talking about this problem of, the other problems of deep space travel, radiation, meteors, micrometeors, just protection from the vacuum of space itself, having enough supplies for the duration of the trip, ignoring all those other problems, it's still difficult, dangerous, and possibly nasty business for humans to spend significant amounts of time in zero gravity. And if we send people to anything more distant than the moon, maybe even Mars, we're going to need a much different way of travel. Personally, I'd prefer to just increase their speed and shorten the length of the time that the trip takes so that these problems don't arise in the first place. But more realistically, sending a crew to man a space station near Charon or on a one-way trip to Proxima Centauri will take time. A long time. A dangerously long time to the health of the crew performing the trip. And for now, our best means of avoiding this problem is to build ships with centrifuges and rotating crew quarters to create artificial gravity for the occupants to live in 24/7. Speaking of 24/7, there is no night and day cycle on the spaceship. And that's a whole other problem. That affects the sleep and the personal circadian rhythm. So that would have to be simulated too, on board the ship. But, different topic, different video. In summary, extended space flights require the crew to be in zero-gravity environment for more than a week or two, could be potentially hazardous to their health. And the longer the crew's in space, the more hazardous it is. For even longer flights, possibly to colonize other planets and other solar systems that take years or generations of travel, without solid ground under the crew's feet and gravity pulling on their shoulders, we must instead significantly change the way we build spaceships to protect the health and longevity of the crew in transit. Or maybe instead have people who spend their entire lives in zero gravity. Ship's crews who never return to a planet's gravitational field and just act as pilots, chauffeurs to haul others in some sort of suspended animation in rotating pods to induce gravity. Again, I'm getting ahead of myself since we don't currently have the technology for that. What we can do right now is change the way we build ships. Probably best to build ships in orbit rather than planet-side, so that they can have big rotating habitats and not have to be so strong, not be so reliant on their internal structure, and we can make them larger and not have to worry about aerodynamics and escape velocity and structural integrity and so on. And then, have these big rotating habitats spin and produce their own gravity and spare the crew these health problems during the length of the trip. And, because they won't have to worry about, spinal decompression, they won't have to worry about spinal recompression when landing planetside again. And I've been thinking of this, making this kind of suggestion for years, and much to my pleasure, it's finally becoming the plan. The New Horizons shipyard is planned to be built in orbit over the moon and used as a staging point for sending manned missions to Mars, which I think is paramount. For the survival of humanity as a species, we need to get other people on a different planet other than Earth. And not just living there, but self-sustained there, so that they could survive without us. Not just camping there and us sending them supplies every week, but living on their own, independent of us. I'm sure that'll cause all kinds of political problems, but like I said, for the survival of the species. Pretty soon that's going to, end up like The Moon is a Harsh Mistress. If you've ever read any of the Heinlein's books, that's a fantastic one. I recommend it. Anyway, I have high hopes for this New Horizons project, and what future it may bring us. I think I've reasonably made my point. We need to take some serious precautions in order to ensure the safety of our space crews, because bad stuff happens for extended stays in zero gravity. Thank you for your time and any likes. If you have felt so inclined to leave one, if you're still here, you guys are the best. I hope to see you in the next video when I post the last installment of my 4-part series about faster than light travel, where I will, taking the 3 previous videos into consideration, I will explain how even if we are capable of faster than light travel, why I think we shouldn't do it anyway. I'll let you stew on that one until the next time. Thanks, guys.